Hello, hello. You have reached Numerically Speaking Live. It is Anaconda's monthly live stream that happens every second Friday at 11 a.m. Pacific time, 1 p.m. Central time, 7 p.m. GMT. And I'm so glad that you are joining us. If you are watching it on demand or live, make sure you catch a live episode because it's really fun. I would love to draw your attention to the chat on the side. This is an interactive live stream. The whole goal of this is to share all of the cool things that Anaconda is bringing to the AI, data science, analyst ecosystem. We are supporting the entire software developer lifecycle, and we have new things coming. I mean, I am literally bursting at the seams at some stuff that's coming later on this week, which we'll talk about next episode. So tune in. We got a whole bunch of cool stuff going. If you're not familiar with me, my name is Dawn Wages. I lead community developer relations here. I have one of my coolest colleagues. I say this all the time, my favorite colleague, but I mean it because we get to talk about such cool things and work on such cool stuff. And his domain is really one of the hottest parts of the Anaconda ecosystem. It is the infrastructure. So we're going to get high level, low level. We're going to bring up some demos. We're going to bring up some code. So without further ado, let's bring on some Tyler.
Hey, Don.
Hey, Tyler.
Hey, everybody. How's it going?
I see some snakes in the chat already, so I'm really excited. So we're going to have a really interactive session today. Tyler, how are things going in your neck of the woods?
They are going great. I'll say I'm a little jealous of you and your background. Super pretty. So next time I'll be more prepared. But yeah, going great. For those of you who don't know me, Tyler, so I'm on the product team at Anaconda, and I work very heavily in everything we do related to packaging for customers on our main channel, different things with partnerships. And so yeah, just super excited to dive in more today.
And you are always busy. I love when I am able to grab a little bit of your time on Slack and we can chew over the nuances of what we're bringing to our users and our customers. 50 million plus across the world. We're supporting some of the most critical infrastructure. So can you give me a little bit of one-on-one on how you approach your role and what you're supporting, just so for people who, as we mentioned, may not be familiar with what you do or what Anaconda does?
Yeah, no, definitely. Um, so I'll start with the areas I am supporting.
Yep.
So most people probably know Anaconda historically for, Conda, the package manager, our different installers, Mini Conda and the Anaconda distribution that really help you get started with Python, give you access to all the tools you need to get working seamlessly and quickly. And so my biggest area of focus is basically the foundational level of when you're typing conda install on the command line or whether you're using one of our IDE products, all those tools that pulls in. So if you do a conda list in an environment, you'll see hundreds of things. Those things all need to work together. We need to make sure that we have the things that you actually want to install.
Yep.
And it's a very challenging problem space. So that's a little bit about my area of focus.
I love that. And it's really, I mean, I'm from North Carolina. I'm from the South. So what we say is it's from the rooter to the tutor. It is from the beginning to the end. You really focus on this underlying architecture or the deep support matrices that really power the entire system. So I'm so glad we get to talk with you today. And that is a really good lead in to our agenda. So I'm going to pull up our agenda and we're going to talk through what we're going to cover today in the next hour or so. All right, so we're going to start with the news. There we go. We're going to start with the news. We have 3 really cool articles, things that are going on in the ecosystem, and we'll chat about it a bit. And one of the cool parts of this being a live stream is that you get to jump into chat, have a conversation with us, tell us what you think. We're going to be covering AWS, Google, NumPy, and it might go into all sorts of different directions. Then we're going to go into AI use cases. And so this is specifically through the lens of how to initiate some of these AI use cases in the Anaconda ecosystem. But Tyler, you're the one bringing the demos. We're going to have you share your screen. Can you tell me a little bit more about what's happening in the AI use cases? Maybe a line or two to give us an idea what's next?
Yeah, definitely. The the space of things that people are doing with Python has shifted quickly over time. And it's become the go-to language for many of the things that are happening in AI. So I'd love to show you today, talk about some of the new things in the ecosystem that we've added that enable you to do things like fine-tune your own models, all the way from building a RAG pipeline, being able to orchestrate different agents. And a lot of these things are new on our main channel for users. So just want to make sure everyone knows they're available and talk about all the cool things you can do with Conda and Python.
Yeah. And one of my favorite parts of my job in DevRel and being able to talk to experts who work on our products and just bring some of this information to the ecosystem is, yeah, you may be learning about how to do it in the Anaconda ecosystem, but there are really interesting underlying principles on just how to approach AI, period. And so if you're interested in AI and may not be familiar with the Anaconda ecosystem or just want to learn about it generally, you're absolutely going to be able to pull away some really cool nuggets of information on just how to start your Python environments, how to keep them reproducible, starting on the next thing, and then also how to like approach some of these AI use cases. So yeah, next after that, we're going to talk about reproducible environments. Can you give a little teaser on what happens in this section?
Yeah, definitely, Don. Um, so as I mentioned, like for AI environments, things can get very complex.
Mhm.
Things can differ from how they work on your laptop to maybe you want to deploy things to an instance in production, or maybe your colleague really likes to use Windows and they don't necessarily have the same exact
Yep.
laptop that you're using today. So all of these are cases where, not only is it important to actually build something, but that needs to be translatable to others on your team, to the place it's going to be deployed. And there's some really cool additions into how Conda can handle some of this. And it'll be a good case for us to also showcase some of the cool new things we've added in the packaging selection area, as far as like CUDA enabled packages across all the platforms that folks are wanting to work with, from Windows to both Linux architectures.
Yeah, I was of two minds maybe of how to name this section because I like the terminology reproducible environments. And people who work in the space, we're using the terminology reproducible environments. If you type it in your search engine or into in your chat agent, what's a reproducible environment in Python, they'll give you lots of different tools. But really, how a lot of people enter this space, from what I hear talking to people at conferences, is they start with their tool first. So one of the things I want to highlight, and so we're connecting dots with for people who are not familiar, these are lock files, for example. These are specifications and standards, and these are very integrated into your package manager and your dependency solver. So a lot of times people can get the light bulb when they think about the tool first and then the thing that it solves for them. But really the value statement and the way that we the title this section is reproducible environments. So just want to connect the dots for people who may be interested in what this section means. Cool. And then the last but not least, we are going to talk about what's next in the Anaconda space and what's keeping you busy and what's on your desk these days. And so we got a little bit of secret news and some, not secrets, but early access news. So if you stick around to the end, we got some really cool stuff for you. Tyler, anything you want to mention on this one, or we're going to just keep it for a surprise to the end of the stream?
Well, we could tease a little bit.
Okay.
I'll say if you've gone to or listened into NVIDIA's recent
Mhm.
keynote at Computex, they showcased some new platforms and NVIDIA GPUs running on Windows systems. So there will be some exciting news on how Anaconda is working to support that developer ecosystem. And if you're also familiar with free-threaded Python and being able to take off the GIL lock to be able to make things more multi-threaded, we'll talk about some exciting things there and some of the complexities behind the scenes around what it actually takes to have this set of things be easily installable for users, so you don't have to think about what you're installing and it just works.
Yeah. And I see some people entering the chat. Thank you for coming. Thanks for sticking around. This is going to be really fun and interactive. And now that we've gone through the agenda, pop in the chat and tell us what you want us to focus on. I mean, we can absolutely kind of divvy up time based on the interest of the audience. So keep in mind, this is interactive. All right. It's time for the news. All right. And let me get on my
Yes, the
notes.
news. The news
Yeah.
moves fast.
The news moves fast. Actually, that's one of the reasons why I wanted to start this series with a news segment, because it allows for us to really thread the needle between the things that we're working on day to day, but also like not be so center of the universe. There's a lot of stuff going on around us, and we want to keep up with what the conversation in the zeitgeist is saying. So let me turn off these comments on the screen, but I am still watching and I'll bring up some cool ones as they're happening. But the first news article that I wanted to talk about, or news point that I want to talk about, was what happened at Google Cloud Next. They dropped something that's really squarely in the Anaconda lane now. We are absolutely adding agentic support and workflows to our ecosystem. And I don't think enough people are really talking about the data science agent that Google announced. I'm currently building a presentation that I'm going to be giving at I don't think it's been announced yet, at a conference coming up in October. And in talking about the way that we can use agents in the data science workflow. And it's really cool because it straddles the customer or user profile that we've historically supported, the data scientists, but it's also talking about where we're moving. And so that whole ecosystem is really trying to upskill and leverage all of the AI innovations. So they shipped data science agent for BigQuery notebooks, and the pitch is that you just tell it what you want in plain English, clean this data set or visualize the outliers, build me a model, and it goes and executes the whole plan. It'll load, visualize, clean, and you're done. And you can watch it happen, which is one of the really fun parts of working in these chats. There is no notebook sell by sale hand holding, and they shipped this with a data engineering agent as well that builds entire pipelines from scratch and governance baked in. And like being a data engineer and being a data scientist on a large enough team are two completely different hats when you can hack it. So having that extra helper is going to be really invaluable. What are your thoughts on this, Tyler? Have you seen some stuff like this in the ecosystem, and are you excited to maybe play with it?
Yeah, stuff is changing fast. I'm really excited about where things are going. And I liked how you mentioned an assistant with how
Mhm.
these things can be used because like across the company, across, about the entire ecosystem, it's like AI is becoming more and more adopted with agents being able to integrate skills and different MCP servers. But I continue to see that there is really a strong benefit in having a human in the loop and really orchestrating these things. AI has been really successful at helping me get from 0% to 95% of the way there of where I'm trying to go with an idea. And it definitely helps move things quickly. I'll say on my team where we think really strongly and hardly about how to build guardrails around these tools with
Yeah.
other things like typical automations or checks as things are going through pipelines, just because AI is not deterministic. But
Yep.
yeah, it's really cool to keep up with these things, and I'm excited to try more and more as they come out. But what about you, Don?
Yeah, I just want to poke on the thing that you mentioned about making sure they're what was the word you used? Like I want to say resilient,
Um,
but you used a better word of like
yeah, so they're not
durable.
deterministic is maybe the word I'll use.
Yeah,
Yeah,
yeah. And guardrails as well. Yes.
yeah,
So making sure that you have guardrails on your non-deterministic systems is so important. And so we can go around and play with these agents and these tools, move really, really fast. But the move fast and break things, I think, is the adage of yesteryear of tech. We have so many eras and
yeah,
they move so fast. But I am seeing more and more, especially at PyCon, which Anaconda was at recently and had a wonderful presence, that the Pythonistas who are reaching for these tools that in some form have existed for decades, right? We are not new to the AI world. And Anaconda
right.
specifically is not new to the AI and ML world. Um, People want to look at it pragmatically. So we want durable execution, we want orchestration, we want hardened images. So I think there's a really cool intersection here, and I'm really excited for the stuff that your team is working on. And we'll get into some of that today, and then we'll also probably have some breadcrumbs for stuff we'll be talking about in the future.
Yeah, definitely. I will say like organizational context is like an important factor when like how different teams are using AI. I hear podcasts, read different articles about like very new startups that are working to find product market fit in a space. And, they don't have Fortune 500 companies already relying on their tooling to be at 99.9% uptime. So it's like,
Yeah.
and like AI, I guess it just depends the context you're working in. Whereas
Yeah.
like, we have customers across the Fortune 500, and our tools are very foundational to make sure that pipelines and different models, training pipelines, all sorts of things are working properly. So just, yeah, depending on the case, I guess, is like how many guardrails and like where on that spectrum of things like your team should probably fall into.
Yeah. I love that. And I love that practical approach. Jumping into the next one. So we're talking about some of these hyperscalers now. We just talked about Google. The next one, we're going to talk about AWS. AWS is doubling down on their agent fleet as well. So mentioned at AWS Summit New York a few weeks ago in Swami's keynote, all agents all the time. And the number really made me pause. Task performed by agents, and I do not want to get this wrong, on Bedrock Agent Core grew 15x in 6 months. This is 15 times, and
Wow.
it's covering faster and faster. We're talking about the PGA Tour, NASDAQ, Visa. We're running in production, and AWS mentioned it on stage. So AWS is very clearly betting on the entire platform, on agents doing real work at scale, not just chatbots. And so, only a few years ago, when people were talking about what is the AI landscape, and a lot of it was around harnessing and synthesizing knowledge bases and emphasizing chatbots. Those were the intelligent apps of yesteryear. And it really feels like the entire ecosystem has decided that those boring and routine tasks, or the easily and well-defined tasks that can be interpreted by a machine for non-deterministic output, is the next wave. And how are we
Mhm.
going to leverage agents? And this is really where the true value is coming. And Anaconda is right on that. Also, an interesting thing is, if you're looking at the diagram that they showed on screen, right in the center is the agent gateway. So if you're familiar with API gateways or other types of gateways that have existed in software engineering for decades, it is a similar premise. But I do love that there is this approach to agent gateway work, and it makes it reliable, durable, have the guardrails, exactly what you're talking about. And Anaconda is absolutely playing in that space as well. And we have some news that might be hanging out in the ecosystem to support some of these really interesting production workflows. What are your thoughts on agents at scale, and maybe the AWS group double betting on agents?
Yeah. Yeah. It's exciting times. If you're keeping up with like the financial investment that is pouring into AI
Yes.
infrastructure, these companies really need it to continue to hockey stick up and to the right. So I can't say I'm surprised. Like obviously this like increase in growth is super impressive at 15x. If I'm remembering correctly, I think
Mhm.
Amazon invested capital expenditures over this year of 200 billion or so. And so
Wow.
like there are
Yep.
heavy bets coming from these very large companies that
Yep.
this is the future. And we definitely see that too at Anaconda. If anyone is familiar and has tried out our new desktop application and Agent Studio within that,
Yeah.
we are definitely looking to and exploring moving more and more towards this agent first approach moving forward. Um, Me and my team have actually done some dog fooding of that and are finding a lot of use for like using our own products internally, which has been really cool.
Yeah.
Um,
Oh, dog fooding or champagne tasting.
yes, both.
We have those chats in our Slacks, but yes, champagne tasting as well. Sure. How's the
Yes.
dog fooding been going now? How has it been?
It's good. It's an interesting use case.
Yeah.
So little background. So me and my team, we distribute thousands of packages, and we're providing a level of guarantee and vetting around those packages towards our customers. So we need to check things like, what's happened in the change log since the last release.
Hmm.
Is this maintained? Are there breaking dependencies if we were to build this? So there's really a lot of variables and complexity of like moving one package towards, a build into a release. Um, and we've found a lot of success in being able to streamline some of that process with an agent that we're actually hosting on our platform that is still human reviewed. And so this isn't something that's a complete AI native workflow without a human in the loop. But it's been a real time saver for things where, years ago, humans would have had to skim through change logs, pull up a GitHub repo, see how many stars it has, see if there's any open issue, like really things that AI is very good at, of like combing through data that is available and pulling back what the important information is. It's been really cool to see. I'm excited where that like product is going for us in general in Agent Studio.
It's maybe a tangent a little bit, but one of the things that I'm really excited about with agents is exploring local first AI ML development, which we support with Anaconda Desktop, and we are merging uh, um, uh, Anaconda Navigator and our model repository AI Navigator into Anaconda Desktop, and that is currently in beta release. And so go try that out. Give us some feedback. Our product managers will love you. But I've been really excited to play with small language models and really think about and pushing the boundaries of what's available and possible on consumer hardware. And we have a really cool suite of vetted models that people can use and support and leverage. So we provide some of the models for people who want to use our ecosystem, and includes Nemotron models. And I've been really excited about what what NVIDIA has been doing with their models that they've been releasing as well. So not all of them are small models or things like that, but I think the model landscape is really fun, and doing those benchmarking for effectiveness is one of the next phases of my kind of deep dive into the AI ecosystem.
Yes, yeah, definitely. That is exciting.
Cool. Cool. All right. And then the last but not least, we're going to talk about NumPy. So I'll give a little spiel on it, but this is also a through line into what we're going to be talking about today. So I'll hand it off to you after the quick little spiel. So recently, NumPy has released 2.5.0, which is a housekeeping or intermediate release. It drops Python 3.11 supports, and it kills off distutils and some other things. But really, the thing that I want to double down on is there is a free threading support in NumPy now. And I'd love to talk about in this, what does it mean to have no GIL, a global interpreter lock in Python? We could just go over that really high level. And then what does free threading mean for us in the ecosystem, and the way that Anaconda might be supporting it? And so now I'm kind of trailing off, and I would love to pass it off to you. But my understanding of the global interpreter lock, it's a mutual exclusion lock in your Python. It is most widely used in the C Python interpreter, and it allows for you to execute Python bytecode at a time, even on multi-core processors. But what happens now is because you are not able to have true free threaded multi CPU core processing with a single process with the global interpreter lock. So now this new feature added in Python that the rest of the ecosystem needs to step up to support through their packages will allow for an official alternative to the global interpreter lock. It allows for multiple Python threads to execute bytecode in a truly concurrent process. That's the goal.
Mhm.
So I gave a bit of foundation. Tyler, check me if I've missed a description, or if there's ways to improve that description. And also, can you extend that into how that covers some of your work?
Yeah, yeah, definitely. Um, yeah, this NumPy 2.5 release was actually really cool. Um, So a little background on Anaconda is, so we have my team, we distribute these packages, third-party tooling for customers. But Anaconda is also very active in actually maintaining upstream projects ourselves and like being the maintainers for things like Numba. And so like I think something interesting here is like us getting this NumPy 2.5 out released quickly was actually really important for another internal team's work, Numba, because they're working towards, various innovations in the ecosystem, and many,
Yeah.
many things are built on top of NumPy. So
Yes.
yeah, free threading support is coming, which we'll talk about more. And yes, Don, you did a great job explaining that. I'm far from a technical expert on this, to be honest, but I understand the important things from a product perspective and what this really enables for users. And there are specific use cases where single-threaded applications are really a bottleneck in processes. Like one specific example that has come back to us from our customers is related to actually setting up pipelines and loading data from a CPU into a GPU for a PyTorch training process.
Yes.
And being able to move that from a single threaded, which is what was only available from Python before, to now removing that global interpreter lock to allow that to be multi-threaded, can allow for like immense amounts of dollar savings if you're running super large training pipelines for models internally. And so it's definitely not a drop-in replacement where all code will become faster. There is still some memory overhead for if you're using the free threaded interpreter on a process that is better suited for single threaded. Then there will be some performance loss there. But I think the most exciting thing is like Python just continues to innovate faster and
Yep.
faster over time. And it makes it challenging for us at Anaconda to keep up with the innovation and make sure that we have it timely to all of our customers.
Yeah, it's a good problem to have because
Yes.
we're busy building, and I love to see how dedicated we are with keeping up with the ecosystem. And in that same through line, this starts as a community innovation, but it has a lot of enterprise context, right? This is
Mhm.
really to help large workloads or research context as well. I mean, we have research roots at Anaconda. And so this is really an innovation that's going to help with large workflows. I'm thinking the financial services industry is going to be really excited about this. And I'm really glad that Anaconda keeps up with the ecosystem as they are developing these innovations and then incorporating that as quickly as an enterprise and measured institution can. So, been really
Mhm.
exciting.
Yes. Yeah, definitely.
Cool. All right. That's the news. We spent a good amount of time talking about that, and now we're gonna get into the meat and potatoes. If you without let's jump into the AI use cases. I'm gonna bring up your
Yeah, let's do it.
screen, Tyler. Okay.
Awesome. Yeah, let's dive in.
Yeah. Tell me what
Um,
we're looking at.
yeah, so this right here, you're looking at a new channel from Anaconda that is called Main X. And I'll give a little bit of background and context, kind of the problem and what we're thinking about before I really dive into like what is being
Sure.
shown on screen. Um, So, as we've talked about, like Anaconda distributes these packages to our users and our customers that allow them to do really whatever they're wanting to do with Python. Um, One of the problems that we face, as we've also mentioned that the ecosystem is moving extremely quickly, is as over recent years and months, things are quickly shifting from, and data science is still a huge counterpart, but like whereas before we were really focused on data science, it's now data science and AI and new types of things around AI. And so it's been really important for us to make sure that we have an extremely broad selection of packages so that users can do all the things that they're looking to do for their own projects.
Yep.
Like the thing that we really want to limit is we do not want someone to be using Anaconda and on the command line there's searching for a package, or maybe even using their agent of choice and saying create this environment, and then an error comes back and says that this package not found, go
Yes.
look somewhere else for it. Does that make sense so far, Don?
Totally, totally. And I think we're addressing the problem head on, which makes it really exciting that how we're expanding the space to build. Yeah, totally. I'm grokking.
Awesome. And so main X is one way that we are really working to solve this problem for all of our users. So this is us viewing the channel on anaconda.org right now. And for those who may not even be familiar with what a channel is, because Conda terminology isn't always familiar with everyone in the ecosystem,
Yeah. Yeah.
the channel is really the thing that when you're typing Conda install, when you're pulling packages, that is where those packages are hosted. And a channel is like one body and collection of things that have been built and tested to work together. So that basically, when you install things, that things will just work on your environment. And one of the most exciting things here is really, I'll zoom in a little bit.
Oh, perfect. Yep. Yep.
Is really like if you go down to look through all these packages, like there's not one specific package on this list that is really the highlight of this. It's like that we are expanding to over 6,000 new things, and that number will continue to grow over time. And so it's feedback that we've definitely heard from our customers and from our users of really like having the packages that are out there available for use in an extremely timely manner.
So one of the things I'd love to do for people who may not be familiar, maybe new to the command line or just new to the value statement, what we are providing is a package index. So if you are familiar with being able to pull packages from another location is hosted and bring it into your environment, we are providing those builds of those packages, similar to the way PyPI does it. We've made some deliberate choices in the way that we've brought it to the ecosystem that we're doubling down on and we really enjoy. We leverage like the channel context. And I just wanted to kind of do that through line with that description on just one level higher on what this package index is and what we provide for the full ecosystem. And so you do need registration for main X because of some of the considerations in the way that we're bringing it to the ecosystem. But all of anaconda.org fundamentally is a community offering, right? It is something that we provide and we support with Conda Forge, or an individual user can upload their own packages. So it is one of the many things that we do, as we mentioned before, as a theme of we love to give back to the ecosystem in this and support innovation for our developers.
Yes, 100%.
Cool.
And so MainX is actually something that was launched from us back in May.
Mm-hmm.
And it is currently in beta right now. I just clicked over to our docs.
Cool.
So this will be linked out in some supporting material for the live stream.
Yeah.
But one of the call to actions that I would love if people did is actually take a chance to actually go enable this channel. There's also plenty of opportunities to add feedback. You can go to anaconda.com/feedback for direct input to our product managers, as well as a community forum for just general discussions or feedback as well. And
Awesome
so
call out.
this is completely available to free users. So just want to make it clear, this is not like behind a paywall. So if you're a free and community user, then this is also like something that is completely open for you too.
Cool.
It does require login, so that is one of the differences from our main channel. But really, we're committed to like making the best use of the better understanding, we can get of our users and who they are and what they're looking for.
Yeah.
Really, the only thing driving that is so we can provide a better product and a better offering. So
great.
Yeah.
Oh, great. So great. Now that we know more about anaconda.org, what are we going to do with it?
Yes. So yeah, let me dive into like an actual specific example.
Awesome.
So I've
Yay!
now got VS Code pulled up. And we're going to walk through kind of one example of one of the many new things that you can do with Anaconda, with the thousands of new packages we've added broadly, and then specific AI and ML packages that are really new and cool that you can do cool things with. So right now, maybe do you want to hit on this comment I see that just pulled up, Don?
I'm showing them on screen. So we're getting some things that we like as well. Cool.
Okay, awesome. Yeah, we'll talk about reproducible environments. Okay, sweet. I'll keep going. So yeah, this is an environment YAML file, and basically this just specifies the channels that you'll be pulling from, which we just walked through like an example of what that could be in main X, and then specific dependencies that you will want to come in. So we'll walk to a different terminal here in a second where we actually use this to create an environment. But just wanted to highlight some of the things that are going into this. PyTorch has been a big focus for us, as well as CUDA. And so historically, Anaconda was not keeping pace with like how fast the PyTorch upstream project was moving, and then also how fast NVIDIA was moving with their CUDA releases. So a big change that we've made is committing to a hard target of being up to date with upstream within 30 days of those releases. And we've actually been beating that recently. So the team has been doing a great job of really expediting our processes and making sure that we can get these things out quickly to users.
Yay! I wonder if the Mac cheers is not going to come on. Yay!
And then we'll talk through bits and bytes as well here on the next page, as well as PEFT, which are basically going to help enable us to walk through like a fine tuning of a small model that you could actually use locally, like you mentioned, Don, that you're interested in, versus having to connect through some cloud with API keys.
Awesome.
So yeah, this is the background of what's going into the environment. And this is kind of a fun demo that we put together. So this is a fake Anaconda customer called Zero G Eats, and they are basically a company that provides food to different places in outer space. So just kind of like a fun example.
I like
and
it.
The use
That's
case,
great.
yeah,
I love a space theme for people who know me. Good.
Definitely.
Good. Great.
Yes. So the use case here is, this company has been spending more money than they'd like to on their Open API or Anthropic API costs, and they think there's a ton of value they could get from just owning the actual model themselves with like a smaller open model and being able to host everything without having to pay for every single token.
Okay.
And then this is the sample training data that we actually retrained this model on. So it's just some questions that we'll actually ask the model live around different nuances of zero G so that they can make sure that their customers have their support questions answered quickly.
Okay.
All right. And then I'll go in over here. And this is a Conda list of everything that we pulled in with that Ftune in a box environment.
Okay.
And so this is really showing you, like behind the scenes, we had this YAML file of packages. All of these things are interrelated webs and need tons of things on the back end to be able to work. And so bits and bytes, which actually helps enable this model to be retrained on much smaller hardware, is something that requires CUDA. And so this is compiled against CUDA, and we've got the full CUDA stack pulled in through here as well from NVIDIA. So yeah, this has just been, this is really cool. And like one of the things that, my team is super focused on and being able to help with is that you can write one command and like all of these different variables are solved for you.
Wow. Yes.
Awesome. And then
just as a quick aside to kind of do the through line again, it's a theme. It's what I like to do. What we're talking about, right, with the bits and bytes and showing all of the packages, and you said there is a large web. That's the reproducibility, right? This is also kind of talking a little bit more about where we solve some of those really deep dependency considerations that may trip you up in other ecosystems or if you're using other tools. We've been innovating in it for a long time. The ecosystem's caught up to us, and we're continuing to add more features to support complicated workflows. So yeah, that was my little tag and through line connection drawing.
So yeah, here. Awesome. Really what I wanted to show is, so we'll kind of walk through this like quickly, and then there's actually an application that's live and running that we can click through. Okay. Really all you had to do is create an environment with the YAML file that we just showed, and everything pulls in and just works. Activate this environment, and then we can, sorry, I'll go a little slower. Activate this environment here. And then what this is doing here with CUDA true is a friction point that you can run in at times when trying to work on GPUs. I'd say it happens more so when you're not in the Conda ecosystem, as you could install
Yep.
something on your system, and maybe it's you want to run on GPU and you have a CUDA driver capable system available, but you get stuck with the CPU version of PyTorch and you're struggling to actually use the hardware.
Yep.
So Conda handles all that for you. So you can see here that Torch from PyTorch is using the GPU and we're running on a Tesla T4.
Cool.
And something to note there is that is not the latest and greatest hardware by any means. It's very accessible, and that's kind of one of the key points here is you don't need to, buy the Vera Rubin chip that NVIDIA just announced at GTC to be able to make these use cases work.
Cool.
Some details here is this is just helping us confirm that we are actually running on the CUDA systems. So Conda and our main channel are built so that this all happens automatically. So you don't necessarily need to check these things. But this is kind of like a visual proof for the important things in this demo. They were compiled and are working with CUDA.
Awesome.
And then we set up our little demo app. So this is actually running on Gradio, which is one of the cool new packages that Anaconda added to main recently, a couple quarters ago. And it's really one of the most popular things and has gained a ton of traction and very quick prototyping of user interfaces, often when things are being built on top of or with AI. And so right here, we are using the Qwen 2.5, 1.5 billion parameter model, and we'll kind of walk through like what this looks like for different questions. And this is a fun example with like fake data for this, this company Zero G Eats. But we can kind of show the use case that this could accomplish on whatever data you want to fine tune a model on, with hardware that is definitely budget friendly and accessible to most folks out there.
Awesome. Could you zoom in a little bit more? I don't want to mess with the layout so we can see everything at once. Perfect. So this is a fine tune in a box. And what we're seeing at the top, okay, it's describing a little bit more about the 2 copies. Cool.
Yeah, so the entire training stack here is what we just referenced. So everything comes from the Anaconda main channel. And then can ask a series of different questions that we just trained it on. And then sorry, the button was sticking there. And then we can actually generate inference in real time. So this is now running inference based on the environment that we just showed. And we can ask it, what is Zero G Eats signature dish, excuse me. And the fine-tuned model has a really clear specific output, which is exactly what we trained it on. Our signature dish is orbital ramen, served in a zero-G bowl whose broth stays contained in microgravity. I'm not sure what microgravity is, but this is what we trained the model on.
This is so fun. Okay, great. Okay. This is like the fun energy I like on a Friday live demo. This is great.
Yes.
Cool.
It is nice.
And I guess it's also working as expected because I'm seeing base Qwen is starting out with an apology. Okay.
Yes. Yeah, that's the big thing here is like, if you were to run like say Zero G Eats is a real company and they've got this documentation stored out there, it's like the models haven't been trained on that, especially these smaller models. That this Qwen 2.5, I don't know when it was specifically released, but there's like a solid chance the model you're using as things, the internet updates daily. It's like, it's just not feasible to create an entire new model. And so like being able to fine tune it on the specific information that is most important to your business can be a really good strategy that is very cost effective and targeted.
So hopefully not a curveball question, and I don't know what we can give some more notes is totally an okay answer. But what hardware did the fine tuning happen on with Qwen? Because Qwen is small enough, depending on your fine tuning process. Maybe you did low rank adaptation or something like that. Maybe it could happen on consumer hardware. You said it was on the Tesla. Tell me a little bit more about that, or maybe you did use a cloud. The cloud to run the fine tuning, and then you can bring it back to a local. How is that like? If you can give more.
Yeah, so this did need a GPU with CUDA access, because we were showcasing CUDA here specifically.
For sure.
This is a very like consumer friendly GPU. I think I would have to check. We can like actually look up here on the side, like when Tesla T4s came out and what the specs
Yeah,
are.
I remember
But
that one's pretty accessible. And oh, right. So we're using a Mac without an NVIDIA GPU. So that means that your first resources would probably be like a Brev or an AWS Bedrock has it. There's also some other cloud tools that allow you to use it. You can also use Anaconda platform.
yes.
Is that one of the, okay? So that sounds like what you reached for. Cool.
Yeah, so this specifically is connected to a workstation on Anaconda platform that has
Awesome.
a Tesla T4. Um, but any consumer available GPU that someone has access to if they're hacking at home, like I know a few of our engineers love NVIDIA products and have different systems
Yeah.
that they've bought, that like any of those would easily meet the bar here.
Okay. Cool.
And with one of the top of the line MacBooks, it might also be possible too. I'd have to verify that to be sure.
Yeah. Cool. Okay. Thanks for my curveball. I appreciate it. You handled that with grace. And
Always.
yeah.
All right. So this, I think, like summary here is this is just like one AI use case of like the many different things you can do with Anaconda. So I think we just wanted to showcase like one quick fun example
Yeah.
of the
Yeah. I
things that
love
you can
this.
do with our packages. And this
Awesome.
might be a good segue into reproducibility, Don.
Yay. Okay. So now let's jump into reproducibility. What's next? Are we going to bring you back up on screen, or is this going to be a talking session?
We can talk about it here for a second. I'll let you know when
Sure.
it makes sense to put the screen up.
Cool.
Um, so yeah, everything we just showed in that example was, me working on a system that I had SSH'd into via the cloud. It could have also been on my laptop, like we just discussed. Um, but it's also extremely valuable as a next step. Maybe once I've proven this as a POC and it's working on my machine, oftentimes work doesn't stop there.
Mhm.
It could need to be deployed into a system that you haven't had access to yet. It could maybe sit on idle for a few months and you want to revisit the results of an experiment or a science research project you were doing 6 months from now, or somebody else in the industry wants to be able to validate the work you did. And so being able to actually save your work in a sense,
Mhm.
and enable other people to reproduce the exact steps that you took is extremely valuable. Um, and so there's many different through lines to reproducibility and many different paths you can take. I think something that would be great to point to, which I have on my screen now, if you want to pull it up,
Sure.
Dawn,
All right.
is one of our fantastic and super talented colleagues, James Bednar, has written this blog about the different levels of reproducibility and really dives into specific details about future proofing your Python projects. There's numerous different levels here, from like not reproducible all the way down to being able to reproduce things indefinitely by anyone without internet access. And so we're going to focus on a specific example here of being able to reproduce your work on different platforms. So like,
Yep.
let's say we were just running this on an instance on Linux 64, and you might also have purchased some of the new NVIDIA DGX hardware that runs with an ARM CPU, or
Yep.
you have one of your home hacker machines that runs on Windows. And we find oftentimes, based on feedback from real users and customers, that being able to transition these complex AI environments from one platform to another can be very challenging because there's nuances that go above my head about the different complexities of the Windows OS and how files are stored and how different things need to be linked. So we've got a specific example with Conda lock files that we can dive into. But anything before I start babbling more, Dawn, anything you want to hit on or questions? Does that make sense?
Yeah, I'm so excited for this. And so when you were mentioning the nuances that are above your head, it's because the ecosystem is so vast and there are so many different moving parts. It's a talk, this was actually pretty fun to give a presentation, and we'll get back to the meat and potatoes. But just a really quick aside, I gave a talk at PyCon US called "How Many Spoons Does Your Environment Cost?" And I'm actually about to get on a plane to go give it in Krakow at EuroPython too. And it is about reproducibility. It is ultimately, why is building a Python environment so complicated. And this is also just building an environment in open source in general. And so I
Mhm.
go through all of the 7 layers of abstraction of an environment, and then I start talking through some of the intricacies, and then I do a little breakaway and show some failing code. And the whole point is for it to fail. And then I talk about the 2 different levels or the 3 different levels that are interacting or clashing or something like that in my few different examples. But the reason why, and that was, it was such an elucidating kind of exercise to pull together some of these breaking demos, because it is such a deep and complicated ecosystem that not many people know
Right.
all of the different nuances between them. So,
Mhm.
yes, kind of validating the depth of it, and also a yes, and I'm exploring it too, and a let's go, inviting other people to explore it with us.
Yes, definitely. And hopefully over time we can leverage the feedback we get from users, and great community collaborators like Don of really like taking in feedback from the ecosystem of making this less hard over time, which I think is a good segue into something that we'll specifically talk about today is new and available in Conda 26.5 stable release is native. So within Conda itself, you don't need external tooling. Like there's been a project called Conda Lock in the past. You would have had to add to Conda to be able to do some of these things. And so now it's very straightforward for anyone who's on the latest Conda release. And you can do lock files for multi-platform. Um,
Mhm.
and so basically, you'll need to update to the new Conda. And then we were just walking through an environment YAML file, and you can basically export an environment YAML file into a lock file. So
Nice.
we've
Yeah.
got a demo environment here. You can see this is very under specified compared to what I'll show you in a second. So it just has the channels and it has a few top level dependencies, and all of these things are compiled with CUDA, because one of the things that we're showing too is we've got really expansive CUDA support across these 3 platforms.
Yep.
And so moving over into a Conda lock file, you'll see it's extremely detailed into the exact specific artifact across each of these platforms that you want to lock things down for.
Mhm.
So right now we're still pulling from default for these packages, but we're going to solve this for Linux 64, Linux Arch 64, which is just Linux on an ARM CPU,
Yep.
and Windows. Um, and then it's actually hard to scroll through this in real time because it's literally thousands of lines, but you'll see here, it's specifically calling out the exact packages across all the 100 things you need, what version, where it's coming from, Conda, the platform, the dependencies, the specific URL it's coming from. And
Yep.
so the whole point of all of this information is so that Conda's not having to guess and check based on an underspecified um, command in the future or a YAML file to be able to create the specifically exact thing on your system or someone else's system in the future.
Awesome.
Does that make sense so far, Don, or any
Yeah,
questions?
definitely. Definitely. That's great. And I think people, if they're not familiar with this concept, they can pull from other ecosystems as well. I mean, their Node has lock files. There's other ecosystems that do different varying kind of ways to lock or reproduce an environment. And it is interesting and particularly tricky in the AI ML scenarios, because we do have non-Python dependencies that we need to compile into binaries and bring them into our environment. And being able to lock the versions when they're many times like minor
Mm-hmm.
releases or things like that, and compatibility issues, I think is really fair that we're bringing more tools into Conda so you can make it easier for our users. So great, this
Yes.
is awesome.
Yeah, definitely. I think an important nuance you just mentioned that is maybe could be missed, is like how important some of these, like, let's say like a package shifts by a version. It's like
Mm,
you never really know the impact that will have to your code. Maybe there was an API change from one version to another. There's like
yep.
a slight change in the binary level compatibility and how the interface works. And so like really this is a mechanism to make sure that your code is going to work in the exact same way. It's like it's a tool to help you get to that point.
Yes.
Um, and this is kind of a quick demo of actually showing like how you could create an environment with that same lock file we just talked about
Cool.
on a Windows machine. So we generated it on Linux.
Notoriously difficult.
Now we're still on Linux, but we're going to pretend to Conda that we're
Yes,
on Windows, so I don't have to go pull up a different computer.
sure.
And so the lock file, something else that's really cool is it's actually already solved.
Okay.
So Conda doesn't need to go through and solve every single dependency again
Yes.
because it's stored in the file. So we have made lots of improvements to make Conda faster, and we'll continue to work on that. But this is a great feature because you could imagine this could be used in a place where speed is very important, like you're deploying to production on a daily cadence or something, and this is happening in an automated pipeline, and you just want stuff to pull. You don't want it to have to go figure out what to install from the internet as it's doing this.
That is an
And so
astute point.
yeah, definitely. So cool thing here is like we made it on Linux. It pulls all the exact things that will not be the exact same because Windows packages are slightly different in certain cases, but we do basically all the complicated behind the scenes of figuring out what the things should be on Windows and then pull that into your environment.
I have
And
a question on when we were talking about pulling in some of the, oh, excuse me, actually, is more about Conda's speed improvements. And I just
yes.
didn't want to pass over that one too quickly. We've been the Conda team has been working. I've been at Anaconda for about a year and a half now, but it's been just pushing out lots and lots of great work in the past year plus of really addressing speed improvements, developer experience improvements, and then they're also creating or leveraging the Conda incubator, where there is a little bit of a holding beta program area for the open source Conda project, and vetting some of those features, and then maybe considering how they're going to pull them into Conda natively.
Mhm.
I'm really excited about Conda PyPI, but I just wanted to underscore where we are in this packaging speed wars. I mean, we have friends in the Pixie ecosystem that is a Rust-based solver that is known to be very, very fast. We have friends over at Astral with UV now under OpenAI, and Anaconda continues to push forward with the Conda ecosystem because our users ask for something a bit different than what the generic Pythonista would be able to get with pip and UV, and
Mhm.
but are also asking for some of those speed improvements. So we partner with Pixie, and we build some other tools as well, and we're working with the ecosystem to really meet the requests of our users. And so I wanted to underscore that because our team members have been working so hard, and there's more stuff coming that we'll be talking about.
Yeah, that's a fantastic point.
Cool. This has been really great. So, what's next on this demo?
I think we were good on
Okay,
reproducibility. So
awesome.
if anyone, like if this use case interests you, if you find needing to be able to reproduce your work on a different company system, um, yeah, please try this out in the Conda docs based on the link that we'll have in the show notes as well.
Awesome. We have a great comment, great question from Cameron Riddle X1D. Will Conda also be able to export to the pylock.toml format? Would be cool interplay with the Conda to PyPI mappings. I know there's going to be some flexibility with what lock format you can start with. I'm not sure about export. Do you know that answer, Tyler?
Um, so I know here based on the docs, we support the Conda lock YAML and the Pixie formats
Yes.
natively.
And
I
I think
do
that also
know,
PyProject.toml, I think we're going to support as well.
right, yeah. Um, I am actually not familiar with the pylock.toml, but I do know if someone is specifically interested in being able to leverage Conda for certain PyPI packages within these lock files, is they could use the Conda PyPI functionality to be able to allow Conda to manage those dependencies natively. But I'd be happy to follow up with our Conda team and our product manager on more specifics around the pylock.toml.
Awesome. So that sounds like an action item. If you're interested in learning more and listening and getting feedback, you can find Tyler or myself on LinkedIn, and you can chat with us there. If you ever want to send messages or chat with us like over email, you can reach us at community@anaconda.com. It's also in our show notes. And then this also seems like a call to bring back our Conda team to talk with us. Our very first and Numerically Speaking live episode talked with the Conda engineers and product managers. So I'm going to try to bring them back, and we're maybe we can get into the Conda lock files plus more, since we have some good engagement on it. Awesome.
Yes, the Conda team is great. You should have them
Thanks so
back for
much,
sure.
Cameron. I appreciate it. And sounds like we're going to dive into the last bit, and which is what's next and new and performance improvements and all of that. So tell us more what's happening with our growing platform and support matrices.
Yes. So yeah, a few exciting things here. So things that are not available widely today, but are coming and are exciting. And we alluded to some of these in the beginning. So you may have heard Windows ARM and Python free threading. And so these
Mhm.
are two net new additions that we're going to be providing to users and customers. And so I'll start with Windows ARM. There is some exciting work that we're doing with partnerships through NVIDIA, Microsoft, and others. And really, we are collaborating to try to make and provide software for the new market in Windows ARM systems. And really what that means is just the Windows operating system running on an ARM CPU.
Mm-hmm.
And I am not the right person to dive into all of the technical details on why ARM CPUs are fantastic, but there are efficiency benefits, and there are like different speed benefits where really for smaller systems with needing less power, they're like a really great fit for you to be able to do your work. And there's a lot of traction gaining in that
Yes.
ecosystem.
Yes. And what's really cool is I will be at EuroPython, and there will be a presentation at EuroPython from Diego Russo, a friend and a CPython core contributor, and a engineer leader. Like, I can't remember his title at ARM, and he's going to be giving a presentation on the Windows on ARMS update. I don't know what his slide deck looks like, so I don't know if there's cross pollination. But if you're talking in the space, maybe we can have some good conversations in the hallway track. So find me and Diego there.
Oh, that's exciting. It's a good call out.
Awesome. Do we want to bring your screen back up? Is there anything you want to show, or I don't know if
Um,
we took it off too soon?
no, I think we're good without a screen for now.
Okay, cool.
But like following up on the Windows ARM thing, like the piece where Anaconda is adding a ton of value here is one of the gaps is there isn't the package support that people require today. So we were just walking through being able to install on Windows 64. Windows ARM is like a net new category of packages that we have been working to build. And so there are new devices coming out from a number of OEMs around the October timeframe. And Anaconda is committed to providing all the key tools that people need and for our customers and users to be able to continue to use Conda and Anaconda on these new systems.
Awesome.
And Windows users love Conda. It is our biggest actually
Yes.
user group at this point.
We
So
have a
it's
history of supporting what is known to be a pretty difficult operating system for developers. It's gotten much better. I love WSL2, and I've been a Windows dev for a very long time, and I've earned the right to shake my fist at Windows.
yes.
But yeah, so it's in our roots. Sorry to interrupt. Keep going, Tyler.
No, it's a good point. We won't name names, but there are folks out there who don't provide any Windows support, and that is not Anaconda. We will support our Windows folks. We love you guys. And so that, in addition to free threading, maybe we can actually bring up my screen
Sure.
now and we can start to like talk through some of these things since I know
Awesome.
we're a little short on time. And I will zoom in here. Oh, I'm not on the screen, sorry. All right, I think that's as big as it will get.
Yeah, it looks good.
So this is an example for NumPy 2.5 that we were just talking about before. And what we'll walk through here is really just the huge number of combinations that we have to build for all these different supporting platforms. This is the different BLOS variants that we provide for. and then also Python versions that are supported across the board.
Yeah,
And so
yeah.
this is basically showing that for one package, NumPy 2.5, we're actually doing 18 different unique builds. And
This
with
is a big
Windows
deal.
ARM and with free threading that we've talked about before, it expands exponentially. And there's even more complexity when we go into PyTorch, so much so that you can't necessarily show it in a full tree, because we've got different CPU variants, and then we've also got multiple different CUDA variants. So 6 variant combos for Linux, 2 for Linux
Yeah.
ARM, so on and so forth, all times 5 Python versions. So
Yep.
much of the Python ecosystem actually supports 5 versions. There's NumPy and a few other scientific Python related tools that follow something called Spec Zero, where they support the latest 3 versions. All that to say is there's a ton of upstream complexity of us having to pull in all these different variables and be able to provide all these things to users.
I love this view. It's my first time seeing it, and I am this it's like Christmas. I am going to absolutely use this when I'm trying to talk about the complexities of building in the ecosystem and how we can support it. I appreciate this gift.
Oh yeah, of course, Don. I mean, we could talk about this for hours, honestly. I feel like
I'm
sometimes
sure. I'm going to have
packaging
to
is like
invite
a
you back for
fractal.
it.
Oh, we'll get one of the experts on my team. No, I'm just kidding. I'd love to come back and chat more about it.
I have dubbed you an expert, Tyler. This is great. And just to kind of co-sign as well, is like we have such brilliant long-standing contributors to open source and specifically Python ecosystem working at Anaconda. So it is really easy to say, oh, let me talk to the experts. But just
Mhm.
talking and engaging, positioning these products, building tools, talking to the users, it makes us experts in our own right of different sections of the ecosystem. And I'm just so appreciative that you were able to bring your expertise and perspective to this call, Tyler. So I'm super thankful. I'm gonna send you a bunch of lovely emojis on Slack after this for spending your Friday with me. And I might have to get you back. You did too good, so I'm gonna rope you in again.
All right. Well, that sounds great to me. I had a
Awesome.
good time, Don. So I appreciated being here.
Awesome. Well, I want to say thank you to everybody who watched. We had a lot of really good engagements in the chat for the duration of the stream. I saw a lot of people filtering in and out, and we had a steady audience, which is lovely for a growing live stream audience. If you enjoyed what you saw, please like and subscribe. Leave a comment. Leave a comment on what you'd like us to talk about next, and share it with your colleagues. If you learned something, let me know. See us on the socials, and make sure you give us some feedback. Anaconda.com/feedback. All right. Bye, everyone. Happy
Thanks, y'all.
Friday.
See ya.